Okay, you may recall from the last video we measured a cord, and I did a little math, and I got it wrong. 0.042 divided by 0.1 is not 0.004, giving you 4 milliohms. It's 0.42 ohms. The reason I tell you this is we have a new circuit to play with, and I've already built this one because it has a few more parts. Here's the schematic. Battery goes here. This diode is merely to keep you from hooking it up backwards. And it's a little tiny IC chip with 3 legs on it, called an LM317. Out of the 317 comes a 20 ohm resistor. Across it, a 1K ohm variable resistor that picks up some of the voltage developed across this resistor. This will give us a constant 1 milliamp out at the other side. Or 100 milliamps, excuse me. Here's a pictorial showing the thing constructed on the breadboard. And here it is. Negative lead. Power from the 9-volt battery to the diode. We need an output wire. Something to measure. Well, we seem to have lost the 1 ohm resistor. We'll go straight to the cord. We know it's about 0.42 of an ohm, according to our previous sort of crude measurement. Okay, what that's doing is forcing 1 milliamp of current, or 100 milliamps of current, excuse me, through that cord. Let's read the voltage across it. Get a steady reading. This time it says 38.3. That's 0.0383 volts. We do the same calculation as before. We'll arrive with 0.38 ohms. Same calculations, volts, amps, ohms, in the triangle. Cover what you don't know. In this case it was 0.038 volts divided by 0.1 amps, 0.38 ohms. Yeah, you're going to get some variations when you build stuff on breadboards because the connections tend to fluctuate a little bit. Okay, let's come on down the breadboard a little ways and start to talk about a megger. Our megometer, as they're known. We're going to set this circuit up and do a calculation to read a high resistance, 1 megohm in this case. Oh, there's that 1 ohm resistor I was looking for. There's a 1 megohm. Plug it in there. We need a 120k ohm resistor. There it is there. We've brought our ground down, our minus terminal down from the battery down to here with a jumper wire. Let's get ourselves a reference. voltmeter. Let's connect up some current. And let's take a reading. Okay, 855 millivolts, or 0.85, call it 0.86 volts. And the source voltage is, upscale again, 8.71. Let's do a little calculation here. So 0.855 over, and this is a 120K resistor here, but it's paralleled by the impedance of the meter, which works out to be 107,000 ohms. Equals, what was that voltage? 8.21. 8.71 volts minus 0.855 volts. Rx unknown goes there. The process is cross multiplying. Subtract these two, multiply there, divide by that, gives you that. Saves a little bit on formula transpositions. 8.71 8.71 minus 0.86 equals 7.85 times 107,123 equals. Divide that by 0.86 equals 976,686, which is almost a megohm, times 1 exponent 6. Yeah, did something wrong there. Should have been 0.9. Anyway, so we got 0.977000 megohms. And that rounds easily to 1 megohm. About a 1% error there. Well, let's try it with a 4.7 megohm resistor. You'll notice that this one doesn't go up past 2000K. That's 2 megohms. So you can't even read this resistor with the voltmeter. With the ohm meter, rather. Well, let's plug this puppy in. There you go. Again, same process. 0.20, 0.87. Point 20 equal 8.67, or 8.7 it was, minus 0.20 over Rx over what I was doing, 107 K, 107,000 ohms. So we're going to cross multiply those two. Eight 0.7 minus 0.2 equals 8.5 times 107,123 equals, divided by 0.2 equals, and we get 45474500, which rounds nicely to about 4.6K, 4.6 megohms. 4547500. 123, 123. Now 4.55 megohms. Not too bad. We could find out what the actual accuracy is. Minus 4.7 exponent 6 equals divided by 4.7 exponent 6 equals times 100 gives us a 3.2% error this time. Okay, so that's how to make a megarup out of just some resistors and your basic ohm meter or basic voltmeter. Now you notice the voltage goes down as the resistances went up. It was 0.855 there, 0.2 there. Wouldn't it be nice if you had something that went up when the resistance went up? Well, there is such a thing. In my next video, we'll explain that. Okay, this is your basic old-style analog meter circuit. As the current goes up, the needle goes to the right. So as resistance goes down, current goes up, needle goes right. Notice the numbers are written backwards. You'll see why in just a moment. So we've got a 1 megohm resistor here. Let's get a piece of tape. We're going to make ourselves a label for this. Okay, so we know that's 1 megohm. That's 1. We'll go to our 4.7 megohm resistor that we measured in the last experiment. We know that's 4.7 megohms. Okay. So we know that if we put a 2 megohm resistor, which is 2 1 megohms in series, we will have somewhere in between. Let me just plug this sucker in. Come on, you. Guess I'll have to use tools. There we go. So 1 megohm. 2 megohms. And 4.7 megohms. Notice there's not a lot of difference between 1 and 4.7. It's a nonlinear scale, but it is how they did it in the old days. If we want to raise the voltage to 500 volts, we need to share some of the current through this meter with what's called a shunt. If this were 500 volts, you'd put a shunt on there. Most of the 500 volts would be dropped across the resistor under test. And that's megers, or insulation testers, or meg-ohm meters in a nutshell. Thank you for watching.